Computing domains. 1. Computing theory. Computing theory is the branch of computer science concerned with finding out how efficiently a given problem can be solved on a model computer using a given algorithm. Within computer theory are the three main focuses: complexity theory, complexity theory, and formal language. 2. Algorithms. Algorithms are an accessibility describe of method for solving a problem. A great deal of work is done of computer scientists to find most different algorithms solve a problem. For example, the problem of sorting a list of integrants can be solved in any ways. 3. Cryptography. Cryptography is an ancient science concerned with the secret writing that may hiding a message is not appears to be an iterable sequence of symbols, but which can be without some transmission or substitution algorithm be considered back into meaningful message. Stephen Perry, a critical application directly using cryptography collision is, i.e., Internet computing nodes that is designing one's own encryption algorithm or by creating an application of the standard encryption algorithm, many mistakes can be made. 4. Distributed computing. Distributed computing is a means of break up of complex problems. Distributing base the various computers across a network, usually the internet that having that work on the problem currently until the problem is solved. 5. Cloud computing. There are three main ways in which a cloud implements infrastructure as service, platform as a service, and software as a service and structure level. Provide storage and computing power across a network. Compute 6. Computational learning. Computational learning at more competently refers to machine of learning in subfield. This article intelligence, more specifically machine of learning, is a field that is dedicated to the design and development of algorithms and techniques that allow computers to learn. Computer vision. Computer vision is a field of computer science in the go into process video or still image and produce from them of representation of the world. This entails things such as recognition of subject, gestures, and motion. 7. Computer vision. Computer vision is a field of computer science in which a process video or still image of produced from the representation of the world. This entails this such of a recognition of object, gestures of motion. 8. Big data. The idea of big data is very self-explanatory in is the collection of analysis of large amounts of data. It is usually associated with large internet companies such as Facebook and Google. 9. Neural networks. Neural networks are artificial intelligence agents and simulate biological nature structures to process inputs and produce outputs. Earlier, this paper mentioned machine learning neural networks require machine of learning to function useful neural network and are trained on inputs until they recognition patterns and produce peaceful outputs. 10. Tractable problem versus intractable problem. A tractable problem are problems that can be solved in polynomial times x o n k o n l o a g, and an intractable problem can be currently only solved by an algorithm taking exponential time x o to an ONL. The tractable problems can be solved in real sustainable amount of for most values of an while the interval problems can be solved over lifetime. If n is too small to be in any practical use because of the vast is time difference between tractable and intractable problems, much work is done trying to find tractable.
Computing disciplines. If you choose a computing major, what career options are open to you? We have provided information for each of the major lists here. Computer engineering typically involves software and hardware and the development of systems that include software, hardware, and communication. Computer science, currently the most popular of the computing disciplines, tends relatively broad and with emphasis of the underlying science aspects. Information system. Essentially, this is computing is an organizational context typically in businesses. Information technology focuses on computing infrastructure and needs of individual user tends to involve a study of systems, perhaps just software system, but perhaps also system in support of learning, of information dissemination. Software engineering focuses on large-scale software system, employs certain ideas from the world of engineering in building reliable software system. Mixed disciplinary majors. Bioinformatics combine elements from at least biology, biochemistry, and computer science, and prepares students for careers in the biotechnology and pharmaceutical industries or for graduate school in informatics. Some programs may also include elements from information systems, chemistry, mathematics, and statistics. Computational science means science done computationally and serves as a bridge between computing technology and basic science. It blends several fields including computer science, applied mathematics, and one or more application science, such as physics, chemistry, biology, engineering, earth science, business, and others. Some programs also include information systems. Computer science and mathematics combines computer science with mathematics, of course. Some of these programs are found at schools that do not have a full major in computer science. Some are found at universities with very large computer science departments. Gaming and animation, major for student interest in creating computer games and computer animation are being developed at number of schools. This major have various flavor and combine either or both of computer science and information technology, work with either or both of art and digital media studies. Be aware that especially in the newer interdisciplinary areas, different schools use different names for the same subject. For example, one school's bioinformatics, maybe another school's computational biology. Computing knowledge areas. Computer engineering or CE. Computer engineering 2004, the current computer engineering curriculum will soon be replaced by computer engineering 2016 as the ACM or IEE steering committee produced its interim report for review by the computing community in October 2015. Some of the knowledge areas been restricted, like its companion reference curricula. Computer Engineering 2016 describes knowledge area that will lead to a computer engineering program's desired learning outcomes. In addition, it discusses professionalism and the engineering project's effects on society. Computer Engineering 2016 knowledge areas include recruits and electronics, computing algorithms, computer architecture and organization, digital design, embedded system, computer networks, professional practice, information security, strategies for emerging technologies, signal processing system, and project engineering, system, resource management, and software design. Computer science, a unique aspect of the currently computer science curriculum. Computer Science 2013. It is inclusion of the course examples from many diverse universities, which show different ways in which the curriculum recommendation can be implemented. The authors recognize that computer science program should allow students to work across many disciplines because graduates go on to work in such diverse areas as mathematics, electrical engineering, psychology, statistics, fine arts, linguistics, and physical and life science. CS 2013 adds several new knowledge areas to those defined in its predecessor, reflecting that field's tremendous growth in complexity. The new knowledge areas are information assurance and security, networking and communication, software development and fundamentals, and platform-based development, parallel and distributed computing, system, and fundamentals.
Software engineering. The current software engineering curriculum SC 2014 includes the description of knowledge to be addressed in undergraduate software engineering program core, called the software engineering education knowledge, SIG cover the entire spectrum of content for the discipline. Information, terminology, artifacts, data, rules, model, procedures, techniques, processes, and literature. The 10 knowledge areas that make up SIG are computing essentials, mathematical and engineering fundamentals, professional practice, software modeling and analysis, requirements analysis and specification, software design, software verification and validations, software process, software quality and security. Information technology. Information system. The information system curriculum IS 2010 created by ACM and the AIS and endorsed by CS builds on the foundation established in the two previous versions, providing guidance on the curriculum recommendation for information system programs in universities and colleges worldwide. As with the other four curriculum IS 2010, specifics learning outcomes to be achieved the program in this case. The high-level capabilities to be developed are user advocacy skills, the ability to address information and communication, the ability to manage complexity, skills, abstraction, high ethical standard, and extensive capabilities for problem solving across the range of integrated professional responsibilities, technologies, assurance and securities, concern, adaptability, outstanding, interpersonal. Information system. The information system curriculum IS 2010 created by ACM and the AIS and endorsed by CS builds on the foundation established in the two previous versions, providing guidance on the core curriculum recommended for information system program in universities and colleges worldwide. As with the other four curriculum IS 2010, the specifics learning outcomes to be achieved the program in this case, the high-level capabilities to be developed are improving organizational processes, exploiting opportunities created by technology invocation, understanding and addressing information requirements, designing and managing enterprise architecture, identify the evaluating solution and sourcing alternatives, security, data and infrastructure, and understanding, managing and controlling IT risks.